Hey everyone, and welcome back to the Data Idol Summer School. I'm Amy and I'm the Senior Events Coordinator for the Data Science Festival. The purpose of the Summer School is for people that are transitioning into data or just kickstarting their career. We have around 40 sessions available from August to October, and you can watch along with the community. We also have a Slack channel that you can join, and we'll be popping the link for this into the chat during the session. If you'd prefer to watch the sessions in your own time, this will also be an option, which will be available from September onwards. I'd like to say a huge thank you to our summer school partners who have supported us and made summer school happen this year. I'd also love to shout out to all of the speakers that have given up their time to support the data science community. I'd now like to introduce Helen and Thomas, who will be presenting their session, Intro to R. We hope you enjoy and thank you for your support.
Hi everyone, I'm really excited to be spending some time with you today to take you through an introduction to R and its use within data science. So let's start off with an introduction. My name's Helen Anstey and I lead the Advancing Analytics team within Openreach. And with me today is Tom Constant, who's a data scientist within the Advancing Analytics team. We at Openreach are the country's largest team of telecoms experts, and we look after the majority of the nation's broadband and fibre networks. We provide the infrastructure behind over 660 of the UK's communications providers, such as Sky, TalkTalk and BT, among many others, of course. And we have one of the largest engineering workforces within the UK. So we have 28,000 engineers who provide and maintain these services for homes and businesses. Here in Openreach, we use R on a daily basis, and it's our go-to tool for most of the complex analytics that we do, and for many of our data science projects as well. We find R helps us to structure our work, so it's easy to complete the work, and the markdown functionality in R is really useful because it makes creating documentation for the projects super simple. The graphics and the charting, which we'll be covering within the session today, is really flexible, and R can handle a lot of data, and that's something that's really important to us within Openreach because we do have a lot of data. You can see from the slide that we work in really big numbers. A good example of the type of project that we do using R is some of the work we've been doing recently to ensure that customers are receiving good broadband performance and to detect when their service isn't as good as it should be so that we can proactively go out and resolve these problems. This is using the broadband performance data that we receive for every line that we provide in the country, and we connect 32 million homes and businesses to the wider world. And we have line performance data for those lines every 15 minutes, every day. So that means we have billions of records that we're using, and we need a tool that can handle a lot of data, that makes it easy to manipulate that data, to use it within complex analytics, and to do some modelling on it too, so that it's easy to do the modelling and that the model runs robustly. And R is a really great tool for this. There are many tools that we could use, and we do use many other tools within our team, so things like Python. But we generally use R because it's really good at doing both the analytics and the modelling, which makes it a very useful crossover tool to learn. And so with that, I'll hand over to Tom, who'll take you through an introduction to the R tool.
Thanks, Helen. So I suppose we should start with what is R. So R is a programming language designed for statistical computing. It's currently the 12th most popular language in the world, and that's including all languages. For data science, it's probably in the top 2 alongside Python. They're normally mentioned in the same breath. R's focus, though, is it's not a generic programming language. Its focus is on statistics, data manipulation, and visualization. It has a really active and flourishing community, which you can look at on Twitter under the hashtag #RStats, with very helpful kind of data scientists all helping each other out. And because it's so data focused, most of the discussions, most of the information about R relates to data science more than generic kind of Python problems, which is really nice. It's free, available from the comprehensive R network, CRAN. You'll hear CRAN a lot when you use R. And it comes as a command line tool. So it comes just in the console, printing out input from whatever you've put in. For development and for work in Openreach and in general in the data science community, I would highly recommend an integrated development environment such as RStudio. RStudio is the market leader in this, and it's free. And it makes data analysis and managing projects super, super easy. And that's what I'll be using today when I demo some code. If you'd like to avoid all the kind of pain that might come with installing new new programming languages on your operating system, you can try R out without installing anything through the browser using RStudio's cloud, which is also free for a small powered computer. And it lets you basically use the same environment, R and RStudio, but from your browser rather than having to install anything. So with that for today, this introduction is going to be a kind of live coding example of the basics. We're going to run through your first steps in R, what variables are, some basic data wrangling, some plotting of the data and visualization, and then we're going to finish with a very simple machine learning use case of classifying penguins. If you'd like to do this in your own time and follow it along at your own speed, we've actually hosted this tutorial on CodeLab, and the address is there at the bottom, and you can complete that in your own time. So with that, let's get out of PowerPoint and into a development environment. So this is RStudio. This is what it looks like. We have a console here where we will type our commands. We have an environment which will show us our variables. We have a file system browser, and on these tabs here we also have plots, which will show us plots as we make them, packages, which are like add-ons, your help, which is very useful, and a viewer for viewing things that aren't graphics or output, things like HTML pages and things like this. So in RStudio, when you first load it up, it will look pretty much like this. The only difference is I've increased my font size so it plays better on the web stream, and you might not choose dark theme. You can choose various color schemes. So I feel this will show up nicely for what we're going to do. In the console, you can type commands and hit enter, and you will just see the result of them. So let's do a simple arithmetic thing. Let's do 1 add 5, hit enter. The result is 6. That's nice. Now, because we're going to be writing a lot of code and we might want to refer back to code, rather than just typing in the console all the time, I'm actually going to write it in an R script, which is just a text file with R commands in that we can execute line by line, but then we have a file that we can use and refer back to. So for that, we can just click New Document, New R script. And this will open a bit up the top here, which is a self-contained text file that we can save, and we can execute code in here, and it'll be sent to the console, and the results will come out here. So we've done 1 add 5. That's a pretty good start. Let's start with how R deals with numbers and with objects. Every object in R is a vector, and you can even numbers. So to create a vector of arbitrary length, what you can do is you can combine or concatenate using the C function a string of numbers. So say let's do 1, 3, 4, 5. Now when you're in the script window, you actually hit Control Enter, not Enter, to execute the code, or you can click Source to source the whole thing. So if I run that, out it comes, and I have a vector here with 4 elements, 1, 3, 4, 5, created by that command. Simplest stuff to start with. The objects you can store in vectors, there's some very basic types. There's logical, integer, numeric, complex, character, and something called raw. Those are the base types in R, and they're referred to as atomic, which means you can't break them down anymore. And you can store any of those things in a vector. Right, so it's very well and good printing stuff out to the console. How do we store stuff? How do we put things into variables? Well, in R, it's very simple. So let's just create a variable called welcome. And we're going to assign, this is the assignment operator, the string hello world. So that is going to take what's on the right-hand side and put it into a variable named the left-hand side with this assignment operator. You'll notice R uses this kind of arrow rather than equals, like many other programming languages. And it's kind of a personal choice by the authors of R because assignment is not the same as equality. But you can actually use equals in many cases. But after a little while of doing this, it will become complete habit. So I'm going to execute that line. And that's going to create a variable called welcome. You can see it's appeared in my environment called welcome, and its value is there. And if I wanted to print that to the console, I can use the print function on the welcome variable, and it will print what's stored in welcome. So, like I said, everything's a vector in R. So let's create a new variable called fruit. We're going to create a vector with apple, let's say pear, and orange. Now we have a variable called fruit that contains 3 character elements, 1 to 3, and that's how it's represented up in this environment. And that stores all 3 together as separate things. So now that we have that, how do we pull one of those things out? So in R, very similar to other programming languages, you use these square brackets. In these square brackets, you provide an index to which element you want to see. So if I wanted to see the pair object, which is the second character object, I would type 2. Thing to be aware of here is R starts counting at 1. It doesn't start counting at 0 like Python. So the first element is 1 in R. In Python, it would be the 0th element. And I prefer it in R. I think the first element makes more sense in my head. So that's all well and good. That's how you make variables containing vectors. In data science, of course, though, we don't tend to deal with one-dimensional vectors that often. We use kind of tabular data, if you imagine a spreadsheet or something. And for this, R has a type called a data frame. So if we, I'm just going to put a section in here. Data frame. The shortcut for that, by the way, is Control-Shift-R. We're going to make a little data frame to contain some multiple columns. So let's create some vectors first. Let's do fruit color. And we're going to make a vector. What color are they? Well, an apple is green most of the time. Pear is also green. And an orange is, of course, orange. And then let's do some fruit prices. How much is an apple? Let's say 20p. Pear is a little bit more expensive, I reckon. And an orange, probably in the middle. So there we go. I've executed those lines. I've got a variable called fruit with the names of the fruit, fruit color, and fruit prices. Now, to get that into a tabular form, we're going to use a data frame. So let's create something called a fruit shop. Oops. And we're going to make that a data frame. Notice in R as well, R doesn't care about white space, so you can space out your code however you like on different lines and it'll execute all together. So the fruit, let's call it type, is the fruit vector. I did call it fruit, didn't I? Yes. Fruit color. And the fruit prices. Seems like I've double typed here a little bit. But actually in a data frame, this is going to be the name of your column and this is going to be the data that's put into it. So that's why I've repeated myself. And you can, of course, use different names depending on the vectors. You could write the vectors straight in there. And R has many ways of reading in data files. So you can actually just import like a comma separated value or an Excel sheet and it goes straight into a data frame. Let's run fruit shop and then let's have a look at it in the console by just typing its name. And you can see here we've got fruit type, fruit color, fruit prices, apple, pear, orange, green, green, orange, 2, 4, 3. So that's a tabular data. Now, much like the vectors we spoke about, you might want to find an address. You might want to address one of these. You might want to pull out pear or green or 20p or whatever. Same idea. It's still the square brackets. So let's do this on fruit shop. But you're going to have 2 indices now. You're going to have the row and the column. So if we wanted to get out the first row, second column, so we wanted to get out green, we would type 1, 2. We'd get out green. So there's a few other shortcuts that are very useful to know about this. A very fast and easy way to create a vector of numbers is this colon operator. So if I did 1, 5, it'll actually produce integer list 1, 2, 3, 4, 5. So in that regard, if I wanted to look at the fruit shop and I wanted to look at rows 1 to 2, column 1, I can pull out 2 at once like that. If you want to pull out everything, you can actually just omit the last number and leave it blank. Providing there's a comma, it will then pull out the whole thing. So that's the first 2 columns, every row. Every column, sorry. Cool. So that's a very quick introduction to the basic kind of types and kind of operations base R has. Now, the next section we're going to do is data wrangling. Data wrangling is probably one of the things you spend the most time doing as a data scientist, so it's good to know how R does it, and R makes it very simple. Mostly because there's been some fantastic source packages that have been released open source by the community. And one of these is called dplyr. It's part of what's called the tidyverse, which is a set of packages that are designed for data science and all work together quite nicely. They're designed to work together quite nicely, to have common interfaces. So for this, we'll need dplyr, and we're also going to use some flight data called the New York City Flights 2013 dataset, which is basically every flight that came out of NYC in 2013. If you want to install packages, the command is install packages. You see there's a autocomplete to help me out here. And you simply send a vector of the packages you want. So dplyr, say, and the package of the flights is called NYC Flights 13. Now I'm not going to run that because I already have them installed. So I'm just going to comment that out with a hash. But if you are first time running R, you will need to be able to run that. To load a package, use the library function. So if I library, again, autocomplete is going to help me here. NYC Flights 13. Oh, let's call it the right thing. Flights. There we go. Got a warning that my R is a little out of date. That's loaded the flights into memory. And if I wanted to look at the flights, I might print the top of flights. That's the head command. It might take a second. And it prints out the first 6 rows of the flights dataset, as you can see there. There's loads of information in this. There's year, month, day, departure time, the carrier, the tail number on the plane, things like this. So it's a good data set to play around with, to plan, try some data wrangling with. So let's use dplyr. To load dplyr, it's simply library dplyr, like normal. And dplyr has tons of really helpful functions to select, to filter, to summarize, and they're all named almost exactly what you'd expect. So selecting, a bit like in SQL, let's select some columns. For that, the command is select. The first command is the data. We're going to send it the flights data. And we're going to choose, say, the month column and the year column. And if we run that, you see we get returned a data frame with just the month and the year column. So simple enough. One thing, if you've ever come from another programming language, you might notice is that R doesn't quote these things within dplyr, as in it doesn't put it in speech marks. And that can strike fear in many programmers. How does it know what month is? How does it know it's not a variable? And it's down to something in R called lazy evaluation, where R doesn't actually evaluate anything until it absolutely needs to. And the programmer of dplyr has chosen to pass those things, pass the names, and know they're going to be column names. And so that's why it doesn't throw an error when you do that. And it just makes the code a bit neater and a bit nicer. So let's try filtering. Filtering is another very common thing you want to do. The filter command. We're going to put the data in as flights. And let's filter to just January. Month equals 1. And that will return a data frame. And you can see you'd have to go through to completely believe me, but believe me, every month in this data frame is 1 for January. Now, those are two very simple operations. But what happens if you want to do multiple operations? So one thing you might think of doing is assigning these to variables. So let's call that x. And that result goes into x. And then you can filter x to that. And that can get real messy and it can get quite hard to understand. The other thing you can do is you could put the filter and the select inside each other, where flights year, and then outside that, the year has to equal 1. That's pretty messy too. It didn't even work. Oh, because the year's one. That's month 1. It gets messy, it gets hard to read. And this is where something in R comes called the pipe. The pipe is a really useful operator. It's got a shortcut on the keyboard, actually. It's Control-Shift-M. It looks like this. And what it does is it takes whatever's on the right-hand side and it executes it using whatever it's passed on the left-hand side. So whatever this object in gets passed to this function as its first parameter. Now, the reason for this, or the advantage of this, is it makes reading your data science code incredibly easy. So let's do exactly the same thing again, flights, and then we're going to pipe. You don't need a new line, but I'm going to choose to do it. And we're going to select month equals 1. And we're going to, oh, no, that's filter. And we're going to select the month and the year again. So that, I hope you can understand, much more readable. And how it works is the output of this left-hand side goes as the first argument to the right-hand side. And in dplyr, the first argument is always data. And it's very strict about that. And that lets this work. So if I run that, it does the same thing. But you can see, you can imagine if you're doing many steps in a data science kind of pipeline, it makes it far more human readable and easier to understand. So there's two more things I want to talk about with dplyr. That's adding columns and grouping by. Oh, and summarizing, 3 more things. So with flights, if we wanted to add a column, we can use what's called the mutate command. Mutate is to take something and slightly change it. So it makes sense that it's just adding a column. So for this, we'll take the flights data set again. We'll select, just so it's not so wide, let's say the carrier and the distance. Let's have a look at that. So we've got a character vector indicating United Airlines, American Airlines and such, and the distance. And say we want to add on a column here. Now this distance is miles, it's an American data set. Let's put it into kilometers. So let's add a column for kilometers. For that, we can mutate distance, and we're going to call it distance underscore km, so it's a new name. And we're just going to do 1.61, yep, times the distance column. And as you can see, that adds on a column. Let's make it a little bit bigger. That adds on a column called kilometers, distance kilometers, that has converted the one in distance to 1 miles, sorry, to kilometers. And you can do any kind of operation here. You can put functions in, you can put different operators in, and create. You can put case statements in, and create a whole new column based on your existing data. Now, 2 more things worth discussing with data science: summarizing your data. So by no surprise, you can kind of tell now dplyr is quite intuitive in what it calls its functions. So we're going to use the summarize function. In fact, what I'll do is I'll just take this bit of code to save myself writing it again, and we're going to summarize. So we're going to summarize, and then here I'm going to name a column and tell it what the summarize operation is. So we're going to take the average distance, and we're going to take the mean of it, and we're going to take the distance kilometer column. So this is a summarize operation. It will reduce the number of rows down to 1 in this case, and we find the average distance a flight took coming out of NYC is 1,674 kilometers. Now, the last part of data wrangling is you may not always want to summarize or perform operations on the whole data set as once. You might want to do it in groups, where you might want to perform the operation over and over again on different subsets. Now for that, that's very easy. I'm going to take this command again, save myself some typing. we're going to group by something. And let's say we want to group by the carrier. Again, very intuitive in dplyr. It's just group by. And we're going to group by the carrier. And what that's done there is it's summarized the average distance of the mean, but it's done it by carrier. So you get two columns out, the carrier and the average distance for that carrier. And then you can start to see patterns and which one's a long haul and which one's a slow haul and things like this. So that covers data wrangling. Now we have kind of data like this. What we might want to do is we might want to visualize it. We might want to actually plot some graphs. So I'm going to put a section in here. Plotting. Now, R has some really good base graphics, and by base I mean it comes with the base distribution of R, and you can plot histograms, you can plot violin plots, you can plot box plots, you can do density plots, you can do just scatter plots. They all use different functions, and they are perhaps a little more confusingly written because they all have different names and they take arguments in a different order. Now, by far and away, the most popular graphing package in R is called ggplot. ggplot stands for Grammar of Graphics Plots, and it was a book by Leonhard Wilkinson, I think, called The Grammar of Graphics. And his philosophy was you actually you separate the data from the elements of the chart. You have the data, then you also have the bits that make up the chart. And then you have what's called aesthetics, which says how the data maps to the points, or maps to the rectangles, or maps to the lines. It's a very intuitive way of doing graphs. If you don't have ggplot, you will need to install it using the install packages thing as before. Mine's installed, so I'm just going to library ggplot. Actually, the package is called ggplot2 because it's the second version of this. It's kind of a historical thing, but that's the one you want. ggplot original is no longer supported. Cool. So how do you plot using ggplot? So first of all, we're going to need some data to plot. We could use the flights data, but I'm going to use different data called Orange. Orange is actually built into R, so you'll already have it if you have R. And if you look at Orange, what it is it's a collection of trees measured in their circumference as they were at different ages. So it kind of folds back to our little fruit analogy in the first part. So let's plot Orange, and perhaps the first thing we'll do is say, what is the relationship between the age and the circumference? So like dplyr, ggplot is part of the tidyverse, and it'll always accept data as its first argument, which lets us pipe data into it. We're going to call ggplot. Now the second, so you see the first one's data. The second parameter is the mapping parameter. And this is where we define how the values in our data are going to map to certain elements of the chart. So the X value along the bottom of the chart is going to be the age. The Y value is going to be the circumference. And let's color it, I say, the tree. So if I run that now, it actually just produces a blank chart. I'll show you, it produces a blank chart. And that's because although we've set up the mapping, we now need to add pieces of the chart together to represent our data. So we're going to do a scatter plot and we're going to do a line plot. So for that, we're going to add what's called a geometry. We use the add operator in this. The add operator works almost the same as the pipe. And in fact, the author of ggplot really regrets not using the pipe, but they kind of came along at the same time together and he went with the add. Now for ggplot, it's the add, and we're going to add geom. Everything starts with geom if it's geometry. Wait. And then let's also add geom line. So if we execute that, we get a lovely little plot of the age of the orange tree versus its circumference, and it's even added the legend for us automatically, and it's colored them appropriately so that we know which one is which tree. You see they all kind of started off the same size, and then tree 4 did really, really well compared to tree 5. Must be in the shade, tree 5. So some other stuff with ggplot. It's incredibly flexible, and it doesn't just do scatter plots, it does all different types of plots. So as an example, another built-in data set you'll have if you have ggplot is the diamonds data set. Diamonds data set's a really lovely little set of data that collects together lots of observations of diamonds, its carat, its cut, its color, its clarity, its depth, the price, probably the most important one, and the dimensions of it. So it's a really fantastic data set. Let's just have a plot of it. Let's put diamonds and let's go ggplot. I'm going to exclude the mapping. It knows the parameter expecting is mapping, so I'm just going to shorthand it. And I'm going to say X is going to be the price, and the fill color is going to be the cut, say. And with that, we're going to do a histogram. It gives me a little warning there saying the default's 30, but you should always really choose your own bin width. But it's really that easy to create a histogram where the fill of the color here is the cut, and you see most of the diamonds are at this end in the price, and then you get some really expensive ones at this. And interestingly here, it doesn't really matter on the cut. There can be quite a few fair, well, maybe there's no fair, but some good ones that are really expensive. You imagine they're quite big. In fact, that's something we should probably have a look at. So let's take the same data and let's do a little extra bit of plotting. So let's do carat again, which is the size of a diamond's volume against price. Again, I'm being lazy here. I should put X and Y in here. It knows X and Y as the first ones, but it's good practice to put them explicitly. The color is going to be the color. Notice you can use English or American in ggplot, but the actual column name is American color. So we'll name that there. And then the shape of the point we're going to do is going to be the cut, which I think ggplot will tell me off for doing. And we're going to do a point plot of that. Diamond's pretty big, so it might take a second. Let's see what happens. So while that's loading, X is going to be carat, Y is going to be the price. The color of the diamond is this definition of color, and then the shape of the diamond is going to be the cut. And actually what it's done there is it has told me off a little bit, and it said shapes, using shapes for ordinal values is not advised. What that means is for cut, cut's actually an ordinal value. It means it's in order. Fair is worse than ideal. And so it's saying you're not really going to see much insight if you do that, which is a handy little thing to do. For demo, I'm going to do this, but you can see immediately that it's helping me out all the way. So here's our plot. Took a second. And you can see a clear trend here actually in the colors where the yellow, which is J, which is the clearest color, sits to the right of the other colors in price. And you can kind of see these trends coming up all together in diamonds. And then the shape of the point is mapped to this cut, which I did get told off for, but it shows that you can map different aesthetics to different things. If you want any help on any of this stuff, by the way, F1 on any command while the cursor's on it will bring up the help of that thing. And in general, the tidyverse help files are really good and they're really explicit. And they'll also list the different aesthetics you can map for this. So for G on point, we have X, Y. We use shape and we use color. There's also alpha, the amount of transparency, fill, shape, size, and even the stroke of the line around it. So really helpful tip to know, and it will come up embedded in this help tab. So last thing to do is maybe make it look a little bit prettier. So we're going to add some labels. So that in ggplot is labs for labels. We're going to call it title diamonds. We're going to add a subtitle. Carat, yeah, versus price. And then also ggplot's got loads of different themes. Oh, and that's ggplot has lots of different themes. So we're going to add a theme. This default one is this gray one, and it's a bit contentious in the community, but it's kind of accepted as the ggplot theme now. That's fine, but very easy to change it. So if we change it to let's say light, that will plot ggplot. Ooh, no, it won't. Jump on. Oh, haha, fell for my own. I told you about it myself. ggplot uses adds, doesn't use pipes. Still got another one in there. I've got an extra bracket. That's all that is. So 2 mistakes in one. That wasn't too bad. Again, diamonds is a little long, so it'll take a second to plot. But then when it does plot, and it's telling me off again, but when it does plot, you'll see that we have a title now, a subtitle, and there's other things in labs as well. You can do captions, you can rename the axes, you rename the legend if there is one, and things like this. And then theme light will just will make it white, like that. So plenty of customization and loads to be getting on with. So that is a rocket tour through the very basics of data wrangling and plotting of data in R. The last thing perhaps we want to look at is a bit of machine learning, or a bit of actually how you might write a model in R. R is a statistical programming language that's designed exactly for this kind of statistics and this kind of modeling. But the base versions of models, or the many packages that do models, a bit like in Python, can be a little sporadic how they accept arguments, what kind of data they accept, what kind of form of the data they're expecting. So what I want to show you today is a very simple example of what's called tidy models. Tidy models came from the same people who did tidyverse, which made ggplot and made dplyr. It's relatively new. But what it is it's kind of a meta package that brings lots of packages together and enforces a standard on them, so they work together really nicely. So I'll show you this. It's probably the most modern way of doing machine learning in R. It's really useful, and as I'll show you towards the end, when you have to change something in it, or when you want to change model or classifier or pre-processing, whatever, because of this kind of enforced consistency in the package, it's incredibly easy. So let's do some ML. So again, if you haven't installed tidy models, install.packages tidy models. Also, actually, under packages, you can click install and just type it. Let's go back to plots. So that's the library, tidy models. So this is loaded in a ton of really useful stuff. The other thing I'm actually going to load in is reader, which is another tidyverse package that reads external data, and it's very fast and it's very good. There is base versions in R of reading stuff, but this is nice and fast. So for this, I'm going to try and classify some penguins. I actually have the data up here. These are the Palmer penguins. The Palmer penguins were published by Palmer as a study on these different penguins across 3 different islands and 3 different species, and they spent a lot of time doing field work on them and looking at various physical characteristics and trying to write them down. So we've got Chinstrap, Gentoo, and Adele, perhaps. You can see by eye they're pretty different, perhaps. But can we get a machine to tell the difference? And within this data set, there is flipper length, there's beak length, which they've defined here, the island they were found on, the sex they were, and all these different things. So the question is, can we build a very simple machine learning model to predict what species a penguin is from these physical characteristics? So for this, we're going to use the Palmer data. Palmer data is an open source data set. And what I've done for this workshop, because I'm just demonstrating the capabilities, I've done the pre-processing for you. It's an important part of data science, getting rid of null values, kind of imputing missing values, things like this. I've done that for us so that we can just have a nice clean data set to start with. But I will mention the packages you can use to do that pre-processing towards the end. So the data we're going to use is actually hosted on GitHub, or my GitHub, in fact. And I've got 2 data files. I've got penguins analysis and penguins assessment. Penguins analysis is what we're going to use to build the model and train the model. And penguins assessment is the data we're going to test it on. And there's no overlap between these 2, which is really important, right? You don't want to be training on and testing on the same thing. So let's load in this data. We're going to call, I tend to append, this is a personal thing, I tend to append my variables with what type of data it is. So I always start mine with data frame underscore, so I know it's a data frame without having to open it. And I'm going to do data frame analysis is read underscore CSV from the reader package. And what's actually nice about this is you can actually put a web address straight in. and it'll load it from there. That is the analysis one. Again, if you're following along on the code lab, there's download links for this, and that will read in the data frame there. We're going to do the same for assessment. So I'm just gonna, well, I'll just write it again. Assessment. Read CSV. No caps. And I'm going to copy that. Now, there's also one other little thing I'm going to do here, just to make our lives a little easier, because we're importing data like this. And I haven't really covered what this is, but what I am going to do is I'm going to change the species column to be a factor. Factors are a standard way in R to deal with categorical values, and it's what tidy models expects when you're doing stuff. So at the moment, it's just a character vector, but it's going to become so it knows it's a category. And tidy models will check for that occasionally. So we're just going to make sure we're not going to run into any problems. You can do the same thing for this one. Bit of a long line. And let's see if these load. So let's load data frame analysis. There we go. Nice thing about Reader is it spits out a bit of information when it does it. So there's 256 rows, 8 columns, 3 character vectors, island, sex, and species, although we have changed that to a factor now after this call. And 5 doubles, build length millimeters, build depth, flipper length, body mass, and the year it was observed. Let's load in the assessment set as well. Same stuff. Cool. So now we have our data. Let's just print one. Look, there we are. So there's these islands. I think there's 3 islands, various build lengths and stuff, the sex and the year. And one more, yes, one more species, which is off the edge of the screen. This is a very clean data set that I've pre-cleaned for us, just to demonstrate the model. There might be missing values. It's very hard, apparently, to work out what sex the penguin is. So sometimes they just didn't guess and it was missing. I've imputed those using a modal imputation. Probably not the best imputation, but for what we're going to demonstrate here today, it'll be fine. So let's start predicting. Let's try and build a model around these. So we're going to build the model on the analysis set, and then we're going to test it on the assessment set to see how well we do. We're going to need a classifier for this. I'm calling it classifier. You can call it anything you want. And in tidy models, it comes with all these pre-built models. So we're going to start off with a decision tree. If you're not sure what a decision tree is, it's a way of kind of it's almost like a flowchart where you're breaking down and reducing the complexity of the data at each step by saying, well, if it's got a build length over this, maybe it's this penguin, and it becomes a bit of a tree. It's beyond the scope to describe every model in this workshop, but I encourage you to go away and read about them because they are classifying. Classifying is what I'm about to write. They are very interesting. I'm just going to say I'm going to use this for classification, which is the mode. You can use decision trees for regression, predicting numbers as well. So there's our classifier. Now we're going to build our model. We're going to use the fit function. We're going to fit the model. We're going to pass it the classifier. The formula, I'll explain the formula, is this. And this, what it is accepting there is it's saying, what are you trying to predict against what are the predictors you're going to use? So I want to predict the species, and this is the little formula symbol. And the dot means everything else. It's shorthand for everything else. If I wanted to do it just on, say, sex and island, say, I'd write that. That's probably not going to be a great model. But if you just want everything else in the data set, you can shorthand it to that. And the data it's going to fit on is going to be the data frame analysis. So that's our model. We're going to fit it. We're going to fit a decision tree, which is in the classifier, formula, species, data. Let's give that a fit and see how it does. Cool. Gave me a little warning there. The little warning there is saying it's using the engine. So the package it's using its decision tree logic from is called rpart. Good practice really to explicitly define which engine you're using. And if you don't have rpart installed, you may get an error and you need to install rpart. Again, these are all free packages. They take seconds to install, so it's no problem. Right, let's have a look at how that did. So if we want to predict results from this, we use the predict function. We're going to predict from the model, the fitted model. And the new data is going to be our assessment set. And that's key, right? So we trained it on a completely different set of observations. The model's never seen this before. How does it do? If I run this, it will spit out all its predictions in the same order as the data frame. And you can do, and it's in a column called .predicted class. That's fine. It's not totally useful. We probably want the old data with it as well alongside it, so we can see how it did. So we can do that easy enough. So we can, let's assign it to a new data frame, and we're going to bind the columns of DF assessment. So bind columns, each argument is just going to bind the columns together. So it's just going to have continuous columns, providing they're the same length, or if they're not the same length. So let's run that. There we go. So if we look at this, this might be a bit more useful. There we are. So we've got the original DF assessment, data frame assessment, island, bill length, Philippa length, sex year. And then we've got the species, and we've also got the predicted species, which was the .predicted class piece. So we probably want to know how this did. In tidy models, there's one of the packages tidy model loads is called yardstick, and it has these functions to help you assess how well things have gone. Let's start off by plotting the confusion matrix, which is a summary table of how many it got right and how many it got wrong. The truth and the estimate is .class. I'm just saying which class. Just saying which columns we want to compare. If we plot that confusion matrix, we can see when we predicted it was this one, it got 31 right, because that's the truth. It misclassified one as chin strap. Oh no, sorry, it predicted Adele, but one was chin strap. Same for this one. So it did pretty well. Like you can see, actually, it only got 4 wrong out of the testing set, which is pretty good. Let's you can work out the accuracy from this, which is actually just the diagonal divided by everything. But actually, there's a function for that. See, actually, it takes the same arguments. So I'm just going to nick those to save myself some typing. Accuracy, 95.3%. That's pretty good for a first try with a decision tree. But let's try and improve it. This is where the power of tidy models and its underlying packages like parsnip comes in, because if we want to actually change how this works, the code is identical, except for we're going to change the model we use. So instead of a decision tree, let's use a random forest. Again, if you don't know what random forest is, go away and look it up. It's almost a step further than a decision tree, where it averages lots of decision trees and comes to a better answer. So I'm just going to rerun this whole code now. I'm going to actually overwrite these variables, but all I've done is I've changed random forest rather than decision tree. So my classifier is now that. It's going to fit that. It's warning me, notice it's a different package, Ranger, but I have it installed. And then let's have a look. Wow, so yeah, the confusion matrix is looking much better. There's actually only one it got wrong. So it predicted 33 and got 33, 18, 18. And there's this one little persistent guy who we predicted was chin strap and was actually in a deal. Let's just get, I mean, that's a pretty high accuracy, but let's just run the accuracy on that and see what it is. 99%, that's pretty good. That's we're getting there. And just for fun, just one more, because it is so easy. One of the things many people use now, probably one of the most favorite machine learning algorithms, boosted tree model, or XGBoost, you may have heard it of. So let's do a boosted tree. And again, same code. Wow, so it got everything right. And the accuracy was 1. When you're a data scientist, you should be very nervous when something predicts 1. You probably shouldn't trust it completely. And this is where things like cross-validation and checking with different subsamples of data come in, trying lots of models, checking that you haven't had any data leakage through, things like this comes in. But in tidy models, there's loads of packages for this. So I've only just done in tidy models, the packages behind the scenes I've used here are basically parsnip and yardstick to get the values out. But there's actually loads more, and they all follow the same kind of intuitive format that all kind of link together and make sure they're all using the same kind of stuff, and the same parameters in the same order and things like this. So to name a few, to pre-process your data to make sure it's consistently pre-processed the same way, missing values are removed or imputed the same way. There's a package called recipes. To make a whole machine learning pipeline, there is a workflow to do AutoML, so you can try lots of models at once and choose the best. There's workflow sets, which is quite new. And they all have this wonderful common API. So with that is a whistle-top tour and an introduction. I hope you've enjoyed it and found it useful. Like I say, there is a CoLab available for you to complete in your own time if you'd prefer. And today we covered first steps into our how to do variables, data wrangling with dplyr, plotting with ggplot2, and machine learning with the tidy models package. So with that, I thank you for your attention and I hope you found it useful. Thank you.